Hey guys, welcome to lesson 5.5. So, lesson 5, chapter 5. We're going to talk about, now that we know about fractions, decimals, percents, integers, and decimals that terminate or repeat, now we're going to compare them, okay? Compare and order our friends, the rational numbers. Okay, and again, I'd say this is the second harder part of the chapter, and the rest is pretty darn simple. So we're going to go back to rational numbers, and we're going to just kind of list out what all could show up. Okay, let's see. So let's talk about our friends integers. And who's part of the integer group? So we have 0. We have positive natural numbers. So those are the ones we start counting naturally by 1, 2, 3, and so on. Excuse me. And then negative of the natural numbers. So we're just going to call them negative natural numbers. So -1, -2, -3, and so on. Okay. Then we have some other old friends, fractions. So under them we have things like mixed numbers. Generally speaking, there's only a few times I can think of in math when the answer stays improper, not a mixed. We have improper fractions. And I'm not going to list it down because fractions are fractions. But let me add this piece though. Fractions can be positive or negative. So that's a new thing, huh? Okay. Let's talk about decimals. And again, they can be positive or negative. And that includes terminating decimals, which we covered in chapter 3 and throughout the time. And then the ones we just covered in lesson 5.4, though we have talked about them as well before, repeating decimals. So let's see. Let's talk about comparing things that we learned already. Oh yeah, how about this one? When you compare a positive to a negative, positive is always greater. Why? Because it's farther to the right on the number line, yeah. Now let's think back to the situation we had dealt with before, and that was, what if the numbers they want us to compare or order aren't all the same kind of number, okay? So let's talk about that idea. When comparing or ordering, oh, sorry, my daughter shut the door. Different types of numbers, so mixture of that list we have above. They must first. Be rewritten in the same form. So you mean all fractions or all decimals, okay? All, well, you can't make them all integers, but something that you can compare them. Now you can compare integers, whole numbers and their opposites, with decimals and fractions, right? Because you can figure out where those decimals or fractions fall between the numbers that you have. So in the same form, then compare or order. Okay. So some suggestions are, and I'm going to go back to what I've said before. Convert all to decimals. I think that's straightforward. A little bit more complicated, but still doable, would be to convert all to fractions. Okay, and then the other thing is you've got your number line, right? So we could use a number line. Okay, so kind of something that we were talking about in class even as of today. The greatest value, so the greatest or greater, is going to be farthest right. So where, as you're getting farther to the right on the number line, you're going to be greatest. And then the least, that means the smallest of all of them, is going to be farthest left. And then, it's kind of in between there. So the farther right you are, the greater you are. The farther left you are, the less you are. Okay? Now I've obviously run out of room on my screen. I don't know about you guys, so I'm going to go to my next screen and let's get some examples done. So directions are going to ask us to fill each circle, and then there's just a big old empty circle with, and then one of our inequality symbols, greater than, less than, or they could actually be equal to each other to make a true statement. Now, I think you've heard that set of directions before. Okay. So we have 9.7, and we want to compare it to negative 10.3. Okay, without even thinking very hard, we remember this guy. Positive greater than negative. Yep, 9.7 is greater than 10.3. So a little reminder, check signs first. You don't even really need to look at the numbers themselves, the signs. If you have one positive, one negative, the negative's always going to be smaller, the positive's always going to be greater. Okay, what if we have two fractions? Remember, we did this before in chapter 2. We have two options. So I'm going to write the problem twice, and I'm going to show you two different ways to solve this. So what we could do is create equivalent fractions. So we want to come up with a common denominator for 8 and 5. So because, we're not finding the smallest thing we can, fastest way to find a common denominator is just to multiply the two denominators. So 8 times 5 is 40. Okay. Then let's multiply 8 times 5 is 40, so 5 times 5 is 25. And then 5 times 8 is 40, so 3 times 8 is 24. So what we're going to do is, at this point, just compare the numerators. And I know that 25 is greater than 24. So that means 5/8 has to be greater than 3/5. Now, the shortcut way I'm going to show you is just fast tracking what we just did. So instead of recreating those equivalent fractions, we're going to multiply on the diagonals. 5 times 5 is 25. Remember how we saw that one over here, right? And if we multiply in this diagonal, we get 24. Remember how we saw that over there? So basically, this is me creating two fractions with 40 as the denominator, which is the product of the two denominators that are there. So since I know that 25 is greater than 24, I know that 5/8 is greater than 3/5. So that's a second way of doing this. Okay, so now let's try a different problem. Ooh, we've got different forms. Negative 94 hundredths, excuse me, and negative 5/6. Okay, so again, let's try decimals. And again, when they're both negative, it gets trickier. Okay, so we're going to divide 6 into 5. I'm just going to get the negative into the answer. 6 can't go into 5. So they both are starting the same way, -0. Then put in the decimal point, annex the 0, and 6 goes into 50, let's see, 8 times, which is 48. Now, if you're a smart whippersnapper, you're going to notice already in your tenths column you have a 9 versus an 8. So I can already see a difference, okay? But let's say you didn't. Let's just continue. So let's continue dividing. And 6 goes into 23 times, which is 18, and the difference is 2, which means I'm going to get another 3, and it's just going to keep going on. Okay, so here's my comparison. Negative 94 hundredths versus negative 83 hundredths, but with a repeating bar over the 3. Okay, so here's the weird part. The bigger looking negative is actually farther from 0, so he's not big enough. So remember, we can line them up underneath each other like this. Doesn't matter if there's a bar or not. Why? Same, different. So we have to go with the smaller negative is actually the larger one. So that tells us that negative 94 hundredths is less than negative 83 hundredths with a repeating bar over the 3. So if we take that back up to the original problem, which is how you always give me the final answer is the original problem, we get negative 94 hundredths is less than negative 5/6. Okay? Awesome. All right, let's do some ordering. So directions are going to say order from least to greatest. Now, I got to warn you, don't get in, just think every single time it's going to say least to greatest. I'm going to tell you right now, that isn't always going to be the case. Just like I think on your test, it went greatest to least. So we have negative 3 1/3. We have 3.3. We have negative 3 3/4, and 3.5 or 3 5/10. Okay, so the strategy, again, I like to use is this one. Group the negatives. Oops, you'll learn how to spell tonight. And put in order. So if the problem starts with least, then we would start with the negatives. And then greatest would be the positive. So this would be the direction we're heading. Now, if it's the other way, greatest to least. We start with the positives and we end with the negatives. So it's kind of a reverse number line. Okay, so that's the first thing I would do. And then the second thing I would do would be to group the positives. And put in order. And I think you guys saw me demonstrate that in class. I think it makes it so much easier than trying to find, oh, let's get all the denominators the same, or let's divide all of these, okay? So let's start with the negatives. I have -3. Here, let's go back to pink. -3 1/3. -3 3/4. Isn't that funny? They both were the mixed numbers. And then the positives are 3 3/10 and 3 5/10. Okay, and I'm not putting them in any order right now. I'm just writing them how they show up. Okay, so if I think about this, if I had to estimate, I'm going to draw a little bit teeny number line here. I'm going to make it, so here's -3, here's -4. This would be about -3 1/2. -3 1/3 would be about here, and -3 3/4 would be about here. Okay, so what that tells me is that I can get these in order right now. So I'm going to have -3 3/4 is going to be the least because it's farthest left. Then comes the -3 1/3. Okay, now the decimal ones are pretty simple, right? If we're looking at them, they both have the same whole number, but they do have a difference here. So now with positives, the smaller number is smaller. So that would now give me 3.3, and the largest being 3.5 or 3 5/10. So there's the answer to that. Okay, let's do another one. Let's see where I want to put it. Well, if we put it here, it's too blank over here. So we have 2.1 repeating. We have -2.1. This is weird. We have 2 1/11. Okay, and then -2. All right, so let's see what we ended up with. Okay, so let's just put the negatives together. So I have -2.1 and -2. Let's put the positives together. 2.1 repeating and 2 1/11. So I don't know what 1/11 is, so I'm going to do the division. Goes in 0 times, putting it down. 11 can't go into 10, so another 0. So 11 goes into 100 9 times, which is 99, which gives me a difference of 1. So then we bring down, look at this, can't go in 9 times. So what's interesting is this one is 2.09 with a repeating bar over the 0 and the 9. But if I just looked at stuff, let's take the 2.1 repeating, and we'll just kind of do this. And then we'll do the 2.09 repeating. And these are the same, but here we see a difference. So again, the smaller positive is smaller. The larger positive is larger. So that would put, I'm just going to put numbers on these guys. So let's see. The 2.1 repeating, that's going to be our biggest number. So he's going to be at the far right, okay? And then would come the other positive number. So let's look at our two negatives. All right, so on a number line, if -2 is here and -3 is here, so we've got the -2, but then to the left of it would have to be the -2.1. So the order would be, let's see, the very smallest one would be the least, And there we go. Okay, so I know my numbers probably sound backwards, like it should be 1, 2 with the negatives and 3, 4 with the positives, but it's going to work in my brain. So we have negative 2.1, negative 2, then let's see, 2 and 1/11, and 2.1 repeating. And there you go. So this is going to be the trickiest homework I think we're going to have. All right, good luck with this, guys. Talk to you soon. Bye now.